Hello everyone, this is Research on Investments, and today I will be doing a deep dive into TSMC, a global leader in advanced chip manufacturing. So here are some of the topics we will be discussing in this video today. TSMC is the unseen engine powering everything from smartphones to autonomous vehicles, thanks to its advanced chip technology. Meanwhile, DeepSeek has recently entered the scene with revolutionary AI model that performs as well as leading the US system, but at a fraction of the cost. Today, we'll connect these two narratives to see how the evolving AI landscape might affect the TSMC and what that means for investors. We'll look into DeepSeek and will it affect the future of AI and AI spending. So DeepSeek, a groundbreaking AI model developed by the Chinese startup that is turning the AI world on its head. We will cover how it works, why it stands out from its competitors, and impact on the entire AI ecosystem, including a major hardware suppliers like Nvidia, TSMC, and ASML. DeepSeek distinguishes itself through several technical innovations. First, it significantly lowers training costs by using fewer but highly efficient GPUs, and its architecture uses a mixture of experts' design so that only a small subset of 671 billion parameters is activated per task. Multi-head latent attention enable it to handle longer context without needing extra computation. Additionally, its chain of thought reasoning process improves its performance in tasks like mathematics and coding. DeepSeek operates efficiently by activating only the part of its system needed for a specific task, conserving resources. It employs advanced techniques to manage and process information, allowing it to predict several words simultaneously, which improves its overall performance. One of the standout features of DeepSeek V3 is its affordability. The training process requires an investment of under $6 million, a fraction of the cost associated with the other top AI models. Additionally, as an open source model, it allows businesses to access and customize it without incurring licensing costs. Recently, DeepSeek has caused a major market sell-off, but market has rebalanced since then. But the recent concerns surrounding its AI efficiency claims might be exaggerated. I came across a video by Fireship that theorized how DeepSeek model was created, and here's how. First, multiple sources suggest that DeepSeek may have trained its open source AI models using OpenAI's ChatGPT output. This process, called knowledge distillation, allows a smaller AI model to learn from a more advanced one, reducing the computational power needed. If it's true, DeepSeek could have copied OpenAI's R1 reasoning model while spending far less on AI compute, possibly explaining why they only spent $5.6 million to train their V3 model. Second, DeepSeek claimed that it used around 2,000 Nvidia H800 AI GPUs to train its V3 model, which competes with top AI models from OpenAI, Meta, and Google. However, this claim is questionable because DeepSeek is known to have access to significant AI computing power in China. According to Scale AI's CEO, Alexandra Wang, DeepSeek reportedly has around 50,000 Nvidia H100 GPUs. Given this, it's unlikely that only 2,008 H800 GPUs were enough to train a frontier AI model at that scale. Moreover, Nvidia's most powerful AI GPUs are restricted from being sold to China, which means DeepSeek cannot publicly admit to having them. Third, even if DeepSeek's claims about lowering training costs are accurate, they're not disclosed by financial details. We don't know how much they spend on AI research, data acquisition, and data processing, and most importantly, AI inferencing. While training AI model is costly, running these models at scale for millions of users requires massive amounts of computing power. To support high user demand, DeepSeek would need to purchase many more AI GPUs from Nvidia, as large-scale clusters of AI GPUs and servers are essential for handling real-time AI workloads. I believe AI capital expenditure, known as CapEx, will increase because of Jevons paradox. This suggests that AI efficiency will accelerate semiconductor demand. A common misassumption that AI capital expenditure, or known as CapEx, will decline as AI models will become more cost-efficient. In reality, the opposite is likely to happen. This phenomena is known as Jevons paradox. Jevons paradox states that when a resource, in this case AI compute, becomes more efficient and less expensive, overall consumption of that resource tend to increase rather than decrease. While AI training cost drops significantly, AI development becomes more accessible, leading to widespread adoption. More individuals, businesses, and industries will integrate AI into these operations, fueling higher demand for AI compute and increasing AI consumption. As AI models become cheaper and more efficient, companies will continue developing more powerful AI applications. This will lead to greater returns on AI investments, driving even more AI spending. Instead of slowing down, AI capex will continue to grow for years as AI technology improves and become more deeply embedded in our daily lives. The companies best positioned to benefit from this long-term AI booms are the world-leading semiconductor manufacturers, such as Nvidia, TSMC, and Broadcom. Nvidia remains the dominant player in AI chip, and demand for its GPUs will stay strong as AI workloads increase. TSMC, the world's largest contract chip manufacturer, will continue producing cutting-edge AI chips for Nvidia and other tech giants. Meanwhile, Broadcom, which supplies essential semiconductor components for AI infrastructure, will see increasing demand for its product. The ongoing AI investment cycle will persist for many years as AI becomes more advanced, cost-effective, and widely adopted. Companies will continue investing in better AI hardware and software. This means semiconductor companies will remain at the heart of AI growth, benefiting from sustained high demand for their technology. We'll be taking a closer look at risks involved when considering an investment in TSMC. It has benefited greatly from the booming AI demand for advanced chips, especially driven by AI revolution. It faces a number of significant risks. I want to cover these risks from both a micro and macro perspective. Before we address the risk, let's understand TSMC's pivotal role. TSMC is the backbone of today's digital world. It produces over 90% of the world's most advanced semiconductors used in products like smartphones, AI GPUs, and high-performance computing systems. Its clientele includes tech giants such as Apple, Nvidia, AMD, and many more. To mitigate geopolitical risks and to meet global demand, TSMC is expanding its production overseas with new fabs in the US, Japan, and Europe. However, it comes with inherent risks. First, let's discuss geopolitical risks, which are among the most significant factors affecting TSMC. Being headquartered in Taiwan puts TSMC at the center of US-China-Taiwan tensions. Recent export control measures from the US and its allies have forced TSMC to suspend the production of its most advanced AI chips for Chinese companies. This is done to comply with US sanctions amid limiting technology transfer to China. Such regulatory measures not only affect revenue from important markets, but also create uncertainty about future government policies. For example, comments by political figures have raised concerns that shifts in policies, such as proposals by President Trump, could intensify these restrictions further. Also, especially fears about China invading Taiwan are frequently amplified by media and investors, though such claims are often fueled by fear, uncertainty, and doubt. Recent articles from Financial Times have stressed that while such fears are common, a full-scale invasion is unlikely given the catastrophic global supply chain consequences. The US and its allies depend heavily on TSMC. Disrupting its operations would lead to widespread economic and technological fallout. As you can see, all of these major tech companies around the world rely on TSMC to manufacture their top-of-the-line chips. Another important factor is the rising cost of energy. Taiwan, which has long benefited from its low-cost energy, is now facing significant price increase as it transitions away from nuclear power and relies more on imported fuels like coal and LNG. TSMC anticipates that these higher costs will lead to roughly 1% point reduction in its gross margins. While this might seem small initially, over the long term, higher and more volatile energy prices could impact TSMC's overall profitability and production reliability. This risk is compounded by the fact that energy is a crucial input in semiconductor manufacturing, and any supply shortages could further disrupt operations. Market risks in semiconductor industry are well known for their cyclicality. Currently, we're riding a high wave driven by explosive growth in AI and high-performance computing. However, history shows that all of these booms are often followed by downturns. Could there be a global economic slowdown or recession? Consumer demand for electronics and, by extension for semiconductors, could drop drastically. This cyclical behavior not only affects revenue, but also can lead to significant swings in investor sentiment, making it a critical risk factor to monitor. let's address talent and labor risk. TSMC's highly advanced manufacturing processes require a deep pool of skilled workers. While Taiwan has a strong base of talent, expanding operations in regions like the US has proven challenging due to the labor shortages and cultural differences. For example, at the Arizona fab, there has been delays because local union and management had to work through training issues. This results in longer ramp-up times and higher costs. Ensuring a reliable and skilled workforce is essential for maintaining TSMC's production efficiency and quality. So as discussed before, TSMC is the backbone of today's digital world, which makes it challenging to replace TSMC because no one can come close to TSMC since it has the most advanced process node technologies and it provides huge cost advantages over other competitors. Also, it's the largest chip manufacturing, and since it takes 10 to 20 billion to make this most advanced semiconductor fabs, no one can compete with that. To mitigate geopolitical risk and meet global demand, TSMC is expanding its production overseas with new fabs in the US, Japan, and Europe, as mentioned. So to meet the growing global demand, TSMC's strategic move to build advanced semiconductor fabs in the United States is a major step towards diversifying its global manufacturing footprint. In May 2020, TSMC announced its plan to invest $12 billion in a new fab in Phoenix, Arizona. This initial investment grew drastically. In December 2022, TSMC increased its commitment to $40 billion, and later the US Department of Commerce provided up to $6.6 billion in directing fund under the Chip and Science Act. With plan for a third fab, TSMC total US investment now exceeds $65 billion, making the largest foreign direct investment in Arizona history. This ambitious project is expected to create approximately 6,000 high-tech jobs directly, along with indirect supplier and construction jobs. Despite these impressive investments, significant operations challenges remain. So the first fab in Arizona began high-volume production using TSMC's N4 process technology in the fourth quarter of 2024. Its yield rates are already on par with those in Taiwan, which is a major milestone. However, the second fab using TSMC's cutting-edge N3 technology is slated for operations in 2028, and third fab, expected to use even more advanced nodes like 2 nanometer, will not begin production until the end of the decade. These delays, along with higher construction and operation costs in the US compared to Taiwan, pose considerable risk. The US environment involves higher labor costs, complex permitting process, and supply chain expenses that all contribute to a higher overall cost structure. Additionally, labor shortages and cultural differences have required TSMC to bring experienced Taiwanese technicians to train local workers, further adding the delay and cost. In summary, TSMC's US expansion represents a major growth opportunity. It is not without significant operational and production risks, as mentioned. These include delays in fab construction, higher costs due to local market conditions, and inherent vulnerabilities of global supply chain. As investors, it is crucial to weigh these factors alongside TSMC's impressive technological and market leadership. Now let's shift our focus to TSMC growth prospects in the rapidly expanding field of AI. TSMC is at the heart of AI revolution. Its state-of-the-art fabs produce chips that power high-performance AI systems. Think of the GPUs from Nvidia or custom processors used by Apple. By operating at advanced process nodes like 3 nanometer and soon 2 nanometer, TSMC can pack more transistors into a chip, making devices faster and more energy efficient. This technological edge is essential as AI systems demand even more processing power. TSMC's technological leadership is evident in its state-of-the-art process nodes. The company currently leads with its N5 and N3 nodes, and it's set to begin mass production of its N2 nodes in the second half of 2025 and its H16 node in 2026. These advanced nodes enable chips to be faster, more energy efficient, and smaller, a crucial factor for improving the overall performance of AI systems. TSMC's ability to upgrade and introduce new nodes also gives us strong pricing power, as customers are willing to pay a premium for improved chip performance. Looking closer at TSMC itself, the company's business model is built around 5 major platforms: high-performance computing, HPC, smartphones, IoT, automotive, and digital consumer electronics. The smartphones and HPC segments are the primary revenue contributors and are set to drive further growth as demand for AI application increases. TSMC is projecting high double-digit revenue growth over the next 3 years. Beyond individual cost debates, the overall market for AI is booming. Industries from healthcare nuclear and autonomous vehicles to cloud computing are rapidly adopting AI technologies. As the application expands, so does the need for high-performance chips. TSMC's technology is a key enabler in this growth. Its advanced fabs are uniquely positioned to meet the escalating demand for faster, more efficient processors that power AI systems. This isn't a short-term surge, it's a long-term secular trend that supports robust and sustained growth. On a global scale, the AI revolution is just beginning. As industries like healthcare, autonomous vehicles, and robotics adopt AI technologies, the demand for high-performance chips will grow exponentially. Major companies are already committing massive investments to build AI data centers. Even if the cost per chips decreases, the overall investment in AI infrastructure is expected to rise dramatically because lower costs will make AI solutions accessible to broader market, leading to increased adoption and spending. From a macro perspective, the global AI market is experiencing an unprecedented surge in the infrastructure investments. Microsoft, for example, plans to invest $80 billion in AI-enabled data centers in fiscal 2025, with more than half of the investments occurring in the US. Meanwhile, a major joint venture known as the Stargate projects, backed by OpenAI, Oracle, SoftBank, and MGX, and announced by President Trump, is set to invest up to $500 billion over the next 4 years in the AI infrastructure. These huge capital expenditures are not only building state-of-the-art data centers and computing platforms, but are also generating tens of thousands of jobs, ensuring that AI application can be scaled globally. This massive influx of investment creates a fertile environment for the growth of AI technologies, which in turn drives demand for advanced semiconductor. These investments will lower the cost of AI development, foster innovation, and accelerate the adoption of AI across multiple sectors. In this competitive landscape, TSMC remains the key manufacturer partner for advanced chips, ensuring that all these AI platforms have the hardware to support they need to thrive. In the recent forecast from Broadcom suggests that by fiscal year 2027, 3 major cloud companies will deploy AI supercomputers featuring 1 million XPUs each. This bold vision reflects the massive scale at which AI is expected to grow, and it directly drives demand for high-performance chips. Broadcom has reportedly highlighted a 220% year-on-year growth in its AI revenue, pushing its stock to new highs and breaking the $1 trillion market cap barrier. For TSMC, this development is extremely beneficial. As the sole manufacturer for these advanced chips, TSMC is positioned to receive significant orders to meet the increased demand for AI compute power. This not only reinforces TSMC's market leadership and pricing power, but also translates into long-term revenue growth. This strategic relationship between TSMC and chip makers like Broadcom ensures that TSMC will remain an essential player in building the next generation of AI infrastructure. Especially as cloud companies invest heavily in AI, TSMC stands to benefit the most, cementing its role as the engine driving the AI revolution. So now let's look at TSMC long-term guidance. So TSMC is projected a strong 2025 with full-year revenue growth of around 25%. For the first quarter, the company expects revenue to fall slightly to between $25 billion and $25.8 billion due to the seasonal slowdown in smartphone demand. However, this short-term dip is more than offset by the robust growth in AI chip demand. Furthermore, TSMC plans to boost its capital spending significantly, targeting a range of $38 to $42 billion for 2025. These investments are focused on expanding capacity through advanced process technologies and building new fabrication facilities overseas. This strategic ramp-up is designed to support the ever-increasing demand for high-performance and AI-related chips. Looking beyond 2025, TSMC is well-positioned for sustained growth over the next 5 years, with a projected compound annual revenue growth rate of 20%. A major driver for its growth is continued expansion of AI-related chip revenue, which is expected to double in 2025 alone and keep climbing as demand for high-performance computing and AI accelerators grows. TSMC's leadership in advanced process nodes, currently with 3 nanometer and 5 nanometer, soon transitioning to even more advanced nodes such as 2 nanometer and A16 for leader tech companies, ensures that it remains the preferred manufacturing partner for leading tech companies. Additionally, the strategic expansion of fabs in crucial regions, including the US, Japan, and Germany, will help TSMC meet global demand. Even amid regulatory pressures and export restrictions, the company's resilient market position and deep customer relationships are expected to drive long-term value and shareholder returns. Now let's evaluate TSMC stock. I will be using this tool which I developed, and that will help me evaluate TSMC stock using discounted cash flow and multiple earning models. So as of making this video, the stock price is sitting at a $203.90, and these are the latest numbers. As for the metrics, these are the low, mid, and high assumptions. And I believe this reflects my belief and what I think it should be. This is just my opinion, so let's calculate. So if you believe in the low numbers, then the stock needs to fall another 32%. And if you believe in the mid numbers, then it's almost close to the buying price. And if you believe in high numbers, then it's a buy all day. Now let's look at another valuation given by Morningstar. So Morningstar gives a fair value of $273, which is significantly above its current market price of $203, which indicates that the stock is currently undervalued. So will I be buying TSMC stock? To sum it up, TSMC is compelling buy for several reasons. Its robust growth is fueled by the soaring demand for AI and high-performance computing chips. The company's technological leadership, evident by its advanced process nodes, creates a wide economic moat that differentiates it from competitors. Additionally, our valuation analysis shows that TSMC is currently undervalued with significant upside potential. Its strong financial performance, indicating high margins and healthy free cash flow, is supported by disciplined capital allocation. Moreover, while geopolitical and operational risks exist, TSMC has managed these challenges effectively. Personally, I am very confident in TSMC's long-term prospect. I plan to continue buying and accumulating TSMC shares over time. This conviction combines with this strong fundamentals and growth outlook. I hope you guys found this video to be helpful and informative. Thank you for watching until the end. Let me know your thoughts in the comments and see you in the next video. This has been Research on Investments, and hope you guys have a good day. Bye.